Hello guys, welcome back to another video and I'm Ishtaq Ahmed and today we're going to talk about OSI model which stands for Open Systems Interconnection Model. So today we will cover introduction and benefits of the OSI model, functionality of each layer. We will go from the bottom to the top in the layers. Then we will discuss data encapsulation and decapsulation, and then we will discuss what is difference between OSI with TCP/IP model, and then we will discuss how to troubleshoot problems with OSI model. So as you can see here, we got our model at this side. So we first of all at the bottom we got the physical layer, then data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So we will discuss each of these layer in some detail. If you haven't watched my previous video in which we discussed about the ports and protocols, please watch that video because you will need some topics from that video as well. So let's go to the next page. So here we have introduction to the OSI model. So what is an OSI model? So the Open Systems Interconnection model is a conceptual framework that standardizes the functions of telecommunication or computing systems into 7 distinct layers. So what is this OSI model for? It is for network plus certification. So this model provides a structured approach to understanding network communications and is fundamental for the CompTIA network plus certification. So we got all of these layers here. So on the physical layer, we will discuss about the cables, hubs, NICs. We will not go in that much detail, but we will do a overview of these layers. So then we got the data link layer, which uses the MAC addressing. As you can see, I have defined many of these topics in my shorts. So then we will go to the network where we have the IP addressing and routing. Then we got the transport where we see what kind of protocols we are using. Is it our TCP or UDP? Then we will go to the session layer, presentation layer, and then application layer. Here we also discussed some of the protocols in the previous lecture. So let's go to the next page and discuss. So what are the benefits and what is the purpose of this model? So this model serves several critical purposes in networking, offering significant benefits for understanding, designing, and troubleshooting network systems. So it defines a clear standard for each layer, ensures communication between different vendors, hardware and softwares, fosters an open system environment. So different vendors can create compatible products that work together seamlessly. That's the what is the purpose of this OSI model. Then it also helps in troubleshooting problems. It's a layered approach, allows isolation of problems, streamlines the troubleshooting process. Administrator can systematically check each layer. So when you got the each layer, it's easy to troubleshoot problems in the network. So if a user can't access a website, check each layer from physical to application. Then it is a standard. It's a standard of development. It provides a common reference point for developers, enables products that adhere to established protocols. It accelerates innovation and reduces compatibility issues. So standardization speed up deployment of the network components. So here we learned about what is the purpose and benefits of OSI model. So in next page we will here we get again the 7 layers of the OSI model. So what each layer does is we got a physical layer, cables, hubs, NIC got network interface cards, bits. Then we got all of these things. So to memorize this OSI layer, we have this mnemonic device. So we can remember all of these layers by please do not throw sausage away. So P for physical, then data, then network, then transport, then session layer for S, and the application layer A. So this is the one. There are many others like this to remember the OSI model. I use one of mine. I created that so all people sleeping through networking dot pass. So I learned that so I could remember the OSI model. So on application layer, we will discuss the direct. It's a direct interface for end user applications. On the presentation layer, we got the data translation and encryption. On session layer, it establishes and manages sessions, like we got in website, etc. And on transport layer, it ensures the reliable end-to-end communication. And on network, it's a logical addressing and routing like IP addressing, etc. On data link layer, node-to-node data transfer. So we will discuss on what happens on data link layer, like we assign the MAC addresses of the devices, so users can access them on the network. So let's go to the next page. Yeah. So here we have some overview of the bottom on the top layer, application layer. So what is the function of this layer? It direct interface for end user applications to interact with the network, provides network services to the applications like HTTP, FTP, SMTP, and DNS. So these are the protocols. This protocol HTTP. We use it for the websites. Then we got the file transfer protocol, FTP. Then we got the simple mail transfer protocol. Then we got the domain name servers. So all of these we use in the application layer. When we got an example here, when typing a URL to a web browser, the browser uses HTTP at the application layer to request a web page from a server. So yeah, we use on the application layer every day these protocols. Then what happens at the presentation layer? So its function is responsible for data translation, formatting, encryption, and comparison. Ensures data is presented in a format that application layer can understand. So its key functions are character encoding like ASCII characters or Unicode, and data encryption and decryption, and syntax and semantics handling. So like on the back end we get the code in the back end. So the presentation layer like helps us to be able to see that code on the application layer as a good UI. So it often uses SSL, TLS protocols for secure communication, and also acts as a translator between systems. Then we got a session layer. So what the function of this layer is it is establishes, manages and terminates communication session between applications, coordinates communication between different applications. So its responsibilities are session setup, initiating connections, maintenance, managing data exchange, tear down, gracefully closing the sessions. So like we use WebSockets in our application like for real-time data transfer. The session layer like establishes the connection and also terminates it, and also manages the communication between the backend and the front end. Also we got session cookies in the website that we hold. So the example here is ensure that conversations between applications are orderly and that the data from different applications does not get mixed up. So it manages all of your browser tabs. You got different tabs on your browser like websites open, and then the session layer like manages everything there, all the session keys, etc. So let's go to the next three layers. Okay. Yeah, this is on the middle layer, transport layer. So what is the functionality of this transport layer? So it is very important layer in the OSI model. So the transport layer provides end-to-end communication services, ensuring reliable data transfer between hosts. So it segments data from the session layer and resembles it as at the destination, managing flow control and error recovery. So it's the fourth layer in our OSI model. So what are the features? What are the protocols? These are two protocol types, the TCP and the UDP. So here is also comparison of each, what are their features. So first of all, reliability. In reliability, TCP is a reliable protocol which guarantees the delivery. and UDP is unreliable, so no guarantee that your communication will be successful. So then there is a flow control. Yes, it manages the data rates, and the UDP does not. Then we got the error checking. TCP it uses the checksums and acknowledges, but UDP uses minimal, just checksum only. Then ordering, yes, in order delivery, and no out of order. So overhead high connection setup, so it uses like frames on the network, so which are like we got the high overhead, with got also the IP addresses, and all the OSI layers have the layer on that frame, so it got a high overhead. UDP is minimal header, and the use case is web browsing, email, and file transfer protocol. So we use TCP for them and UDP for video streaming, DNS, and voice over IP. Voice over IP, video streaming, we do it on the YouTube and domain name servers here. So exam tip, remember that TCP is reliable but has higher overhead, while UDP is faster but less reliable. Okay, so let's go to the next three, hopefully. Okay. So here we got the network layer. What are the function of this network layer? Logical addressing and routing data packets across the networks. So it kind of manages like all the packets which cause the IP addresses, and this layer routes them to like their destination. So our routers that we use, the network routers, they got all of three layers. So we connect them with the physical layer, then there's a data link layer, and also the network layer. So what is the data link layer? So its function is node to node data transfer within the local networks. So key element, MAC addresses. As our devices have MAC addresses, so devices switches. So we got the network switches and hubs. They use the data link layer, and they perform the MAC addresses. So they are used to like transfer data packets from one place to another. Then we got the physical layer like cable, hubs, network interface card, like physical devices. We got elements or electric physical specifications, and the transmission and reception of the raw bit stream. So as we know that on the wires, on the cables, the data is transferred in bits. So if it will be like 0 and 1, they are like electrical signals. So 0 means no electrical signal and 1 means electrical signal. So how this is how the data works, and like all of our devices, like mobiles, like computers, binary stuff. So let's go to the next page. We got the what is the data encapsulation and decapsulation. So we got a nice animation here. As data moves down the OSI layer, each layer adds its own header and sometimes trailer to the data. So when we send the data from the application layer, it goes through all of these layers, like the green one. You can see the green one moving down. So it goes to the physical layer and then out into the network. So all of these encapsulate the data packet with their own header. So when we receive the data back on the other end, as you can see, this data is coming from the bottom. So it goes through the wires back to the physical layer, then back to data link layer, and then back to the user UX, so user can see it. So what are the like benefits of this? So is a modular design allows each layer to perform a specific functions independently. Each layer only needs to process information intended for it, facilitates communication between different systems and networks. So it is really helpful in the networking. So it kind of handles everything like when the data goes to the application layer, it handles its stuff, then it goes to all of these, and that's really good for the networks. Let's go to the next page. So here's what is different between like TCP/IP model and OSI model. So we got the 7 layer in the OSI model, and it is a conceptual model. So we actually use the practical implementation here. we use the TCP/IP model. So we've just put these three layers, these three presentation and session in the application layer, and then we got the transport layer, then we got the network layer, and we have put the data link and physical layer in the link layer. So here are some key differences. So OSI is a 7 layer, TCP/IP is a 4 or 5 layers. OSI purely conceptual, TCP/IP practical implementation. OSI equal emphasis on all layers, TCP/IP stronger focuses on layer 3 and 4. So 3 and 4 there is a transport and network layer. So they are really important in the TCP/IP model. So here is that, and let's go to the next page. Yeah, so here is a guide for troubleshooting with the OSI model. So bottom-up troubleshooting. When user report connectivity issues, systematic check each layer starting from the bottom physical and working your way up to the application layer. So for example, I cannot connect to the website. So we will go to the transport layer. First we will check the physical layer, like check the cable or power, if we have the network interface card working or our internet is working. Then we verify the MAC address. So is our MAC address is like working with the router. So then we check the IP addressing. Is the router is assigning the IP address to our device so it can communicate. Then we can also see the ports, verify if the ports are enabled, like for HTTP we got the port number 80. So if it is turned off on our device, so we will not be able to access the internet. So by systematically checking each layer, you can pinpoint that exact layer where the problem resides, reducing the troubleshooting time. So if we don't have these all layers, we will be really frustrated, like we would never found the problem. So here are some key memorization points. So layer names and numbers. We should remember all the 7 layers in order, both ascending and descending. Then we got the protocol data unit. So on layer 6, 7, 6, and 5, it's a data. The layer 4 is a segment. So what kind of the data unit is on each layer? So on layer 3 we got packets, on layer 2 we got frames, on layer 1 we got bits. So it's a physical, then we got data link layer, then we got network layer, we got the second layer, transport layer. Fourth is a transport layer. So what are the primary devices? So in layer 1 we use hubs, repeaters, and cable. So it is the physical layer. Then we got layer 2 switches and bridges. Then we got layer 3 routers, layer 3 switches. Then we got layer 4 and 7 for end device software. So application layer, as we read it before. So end devices software. So what are some protocols? These are key protocols. They can be common to MCQs, etc. On application layer, we use the HTTP, FTP, SMTP, and DNS. Then we got the layer 6, SSL, TLS, ASCII characters. Then we got the layer 5, NetBIOS, RPC. Then we have the layer 4 where we use the TCP and UDP protocols. So thanks for watching this video. I hope you guys like all the knowledge that you have learned in this video. So please like and subscribe to my video. And if you haven't watched my previous video, ports and protocols, I know there was a sound problem in that video, so I fixed that in this video. Please tell me in the comments that it is good now. So hope you guys learned something new today, and see you in the next video.